Imagine you are at home on an ordinary afternoon. You have done nothing wrong. And then there is a knock at the door, and it's the police, and they have a warrant with your name on it. They handcuff you in front of your family, in front of your neighbors, and they take you away. You keep asking what this is about, and no one really explains. You spend hours, maybe days, in a cell, confused, humiliated, terrified. And the reason all of this is happening to you is not a witness, not evidence, not a fingerprint. The reason is that a computer looked at a grainy image from a security camera, compared it to a database of faces, and decided that yours was the closest match. A machine pointed at you, and the humans believed it. There was no lineup, no eyewitness who knew you, no physical proof tying you to anything. There was only a similarity score on a screen. This is not a scene from science fiction. Versions of this have already happened to real people. And the technology that made it possible is spreading quietly into police departments, streets, and public spaces all around you, right now. So let's talk about how a face becomes a suspect, and why the machine doing the pointing is far less reliable than the people trusting it seem to believe. To understand how this goes wrong, you first have to understand how it's supposed to work. Facial recognition doesn't actually see a face the way you do. It turns a face into numbers. It measures the geometry, the distances and patterns that make up a set of features, and converts them into a long string of values, a kind of mathematical fingerprint. When investigators have an image of an unknown person from a camera, they can feed that image into the system, and the software searches through a huge database of faces, sometimes millions of them, looking for the closest numerical matches. Here is the part almost nobody outside the field understands. The system does not return a yes or a no. It returns a ranked list of possible candidates, each with a similarity score. It is, at its core, a guessing machine, a very confident one. It will almost always hand back a list of faces, even when the real person isn't in the database at all. The top result isn't proof. It's a suggestion. But somewhere between that ranked list of maybes and the moment police knock on a door, that suggestion can quietly harden into certainty. And that gap between a statistical guess and a human belief is exactly where innocent people fall through. Now think about the raw material these systems are actually fed. In the movies, surveillance footage is crisp and perfect. In reality, it's often the opposite. A camera mounted high in a corner of a store. Bad lighting. A person moving, half-turned, partly in shadow, captured in a handful of low-resolution pixels. That is frequently the image an investigator drops into the system and asks it to identify. And the software will do its job. It will study that smear of pixels and confidently produce a list of candidates, complete with similarity scores that look precise and scientific. But you cannot squeeze certainty out of a blurry image just because a computer is doing the squeezing. The quality of the answer can never be better than the quality of the picture. When the input is poor, the match is essentially a sophisticated guess dressed up in the language of mathematics. And this is the seductive danger of it. A number feels objective. A ranked list feels rigorous. A percentage feels like evidence. So a fuzzy, uncertain image gets transformed into something that looks and feels authoritative, and a human being on the other end starts to treat a guess as a fact. And here is where it gets genuinely disturbing, because these systems do not fail randomly. They fail unevenly. Large, careful studies, including testing by government researchers who evaluated many commercial systems, have found that the accuracy of facial recognition can vary significantly depending on the face being analyzed. Multiple evaluations have documented higher rates of false matches for certain groups than for others, with women and people with darker skin tones often misidentified at notably higher rates than lighter-skinned men. The reasons trace back to how these systems are built. An algorithm learns to recognize faces by studying enormous collections of example images. If those training images are not balanced, if some kinds of faces are overrepresented and others are rare, the system becomes sharper at recognizing the faces it saw the most and clumsier with the ones it saw the least. The bias isn't a deliberate act of malice. It's baked in silently through the data, but the consequence lands on real human beings. It means the risk of being falsely flagged by one of these systems is not shared equally across society. Some people are simply more likely to have a machine mistake their face for someone else's, and more likely to have that mistake followed by handcuffs. So let's connect the machine to the cell door. On its own, a facial recognition match is supposed to be nothing more than an investigative lead. A starting point, a name to look into, not a conclusion. In principle, a human investigator is meant to take that lead and verify it independently. Find corroborating evidence, check alibis, confirm it's actually the right person before anyone gets arrested. But that safeguard depends entirely on people doing the slow, careful work, and on people staying skeptical of the machine. And that is precisely where the failures documented in real wrongful arrest cases have happened. A low-quality image produces a shaky match. The match is treated as strong. The careful verification that was supposed to catch the error is thin or rushed or skipped. And a person who simply resembles a blurry photo, or whose face the algorithm scored highly for reasons no one can fully explain, ends up detained, booked, and held for something they had nothing to do with. It is the automation of suspicion. The machine narrows the entire world down to your face, and the weight of that machine's apparent authority makes the humans around it stop asking whether it might be wrong. By the time the mistake is uncovered, the damage is already done. The arrest, the record, the fear, the days that can never be given back. And this isn't a rare tool locked in a lab. Facial recognition is expanding into everyday life faster than most people realize. It's appearing in more cameras, more public spaces, more systems that can scan a crowd and flag individuals in real time, often without anyone in that crowd knowing it's happening or ever consenting to it. Think about what that means at scale. It means the ability to identify and track people is quietly being wired into the physical world, and the same accuracy problems, the same uneven failure rates, the same blurry image weaknesses come along with it. A technology that misidentifies people in a controlled test doesn't magically become flawless when you point it at a busy street. The mistakes just get harder to notice, and the stakes get higher, because now the machine isn't answering one investigator's question. It's watching everyone all the time, and any one of its confident errors could land on any one of us. So what do we actually take from this? It is not that facial recognition never works, or that every match is wrong. The point is deeper and more uncomfortable than that. It's that we are handing a guessing machine the power to point at a human being and set real-world consequences in motion, and we are trusting it more than its actual reliability has earned. Every one of these wrongful arrests came from the same root cause, not an evil computer, a machine that was trusted too much, checked too little, and deployed too fast, aimed at images too poor to justify the confidence placed in its answers. The good news is that this is a human problem, which means humans can fix it. It means insisting that a machine's guess is only ever a lead, never a verdict. It means demanding that a person, a careful, skeptical, accountable person, always stands between the algorithm's output and someone's freedom. And it means refusing to let "the software said so" become the end of the conversation, when it should only ever be the beginning. So here's the question I want to leave you with. If a system like this can already mistake an innocent person's face and help put them in a cell, how much certainty should we require before we let a machine point at anyone at all? Tell me where you draw that line in the comments. I read every single one.